Welcome back to AI.Code.Cast. We're doing another deep dive today.
Yeah.
And this one is pretty interesting. It's something that I think a lot of people run into and maybe don't realize how tricky it is. We're going to be talking about searching with wildcards.
Yeah, it's a classic problem, right?
Yeah.
You've got a dictionary, and you want to search it for words, but your search term can have wildcards.
Yeah, so it's not an exact match.
Exactly. So like BT,
Okay.
you'd want to find bit, even maybe boot.
Oh, right, because the period could be anything.
Yeah, the period is a wildcard. It can be any letter.
That is tricky. So like if I'm building, I don't know, a search engine, like an actual search engine, or if I'm doing like autocomplete or something.
Yeah, anything like that.
You run into this problem.
Absolutely.
So how do we even begin to think about this?
Well, you could start with the most straightforward approach, right?
What would that be?
Brute force.
Yep.
You just go through every single word in your dictionary and you check if it matches the search term.
Okay, so I'm comparing each word in my dictionary,
Yeah.
taking those wildcards into account, seeing if it matches.
Exactly. Letter by letter, considering those wildcards.
Okay, yeah. But that seems like it could get pretty...
Insufficient.
Yeah.
Right.
Especially if I have a really big dictionary.
Yeah, imagine like the entire English language as your dictionary.
Oh, wow. That would be...
It would get slow, especially if you're doing this for every single search.
Yeah, you don't want that lag.
Nope.
Okay, so brute force, we can kind of rule that out, at least for big dictionaries.
Probably not the best idea, yeah.
So what else is there?
Well, before we jump into solutions, maybe let's think about the problem itself a little differently.
Yeah.
We're dealing with words. We're searching for patterns.
Right.
Is there any way we can organize those words in a way that makes searching more efficient?
Well, I mean, words, they often share prefixes, right?
Yeah, definitely.
So like, cat and car, they both have that cat at the beginning.
Exactly.
Could we use that somehow?
Yeah, what if we stored our words not just in a list, but in a way that groups them based on those shared prefixes?
Okay, I'm imagining like some sort of branching structure, almost like a tree.
You're on the right track. That's essentially what a trie is.
A tree. Okay.
It's a data structure, kind of like a tree, where each node represents a letter.
Got it.
And you traverse the tree, you follow the branches to find words.
Okay, so like if I have cat and car, they would be on the same branch up until that T and R.
Yeah, exactly.
Okay. Now, how do we handle wildcards in this try?
That's the clever part. When you encounter a wildcard in your search, you don't just follow one branch. You explore all possible branches from that point.
So it's like instead of going left or right at a fork in the road, I'm checking out both paths.
Precisely. It's a choose-your-own-adventure for words. You're exploring all potential combinations.
I like that.
Yeah.
So this is what? Try with optimized wildcard search. Okay. Optimized? Because we're not checking every word, just the ones that might fit.
Exactly. You're narrowing it down.
But all that branching out, I mean, could that get out of hand?
It's possible, especially if you have a lot of wildcards in your search.
Oh,
That's the worst case scenario.
so it's like very efficient most of the time.
Yeah,
But if someone goes crazy with the periods, it could slow down.
exactly. It's a trade-off.
Gotcha. Now, how do we actually build this try? Like if I want to add a word to it.
All right, so let's say we want to add the word cat to our try.
Okay.
We start at the root of the try, right?
The very top.
And cat starts with C. So we check if there's a branch for C.
If there's not.
If there isn't, we create one.
Okay, make a new branch.
Right, then we move to that C node and do the same thing for A.
Create another branch.
Exactly. And finally, we get to the T. We mark that node as the end of a valid word.
So the path through the try spells out the word. That's pretty neat.
It is. And this structure, it makes searching really efficient.
Okay, but we're all about efficiency here. What if we search for the same word multiple times?
Good question.
Do we have to repeat the whole process?
That's where another optimization comes in.
Ooh, tell me more.
It's called memoization.
Memoization, okay.
That's a fancy word, but the idea is simple. We store the results of previous searches, so we don't have to recalculate them every time.
So like if I search for BT and the try finds all the matches, the next time I search for BT, it can just pull up that answer from memory.
That's it. We're avoiding those redundant calculations.
That's pretty clever. So we've got this try, and now it's got like a photographic memory for word searches.
You got it.
Are there any downsides to this approach?
Well, there's always a trade-off, right? In this case, it's memory.
Okay.
Storing those previous results, it takes up space.
The faster searches.
Yeah.
But at the cost of using more memory.
Exactly.
I see. So if I'm working with like a limited memory device, that might be a
You
problem.
got to weigh the pros and cons there.
Yeah. Yeah, for sure. But thinking bigger picture, this seems really useful in situations where you're doing the same searches over and over again.
Absolutely, like a spell checker, constantly checking the same words.
Right. Or autocomplete.
Yeah, good example.
That would really benefit from memoization.
Definitely. The time saved could outweigh the extra memory cost.
Gotcha.
Yeah.
Okay, so we've talked a lot about tries,
Mhm.
but, some people prefer a more straightforward approach.
Yeah, I get it.
Can we make brute force work for us in this wildcard search problem?
You might be surprised to hear this, but yeah, we can.
Really?
Brute force isn't inherently bad, it just gets a bad rap because it can be inefficient.
Okay.
But what if we could make it smarter?
Okay. How do we make brute force, well, less brute-ish?
Let's go back to the problem itself. We know the search term,
Mm-hmm.
including the wildcard.
Yeah.
What information can we use from that search term to narrow down the possibilities?
Well, we know how long the word is.
Yes. Even with the wildcard, we know the length.
Can we use that?
Absolutely. We can filter our dictionary based on word length before we even start comparing.
Okay, so if my search term is at,
Mm-hmm.
I know I only need to look at 3-letter words.
Exactly. It's like pre-sorting your laundry before you fold it.
I like that analogy.
You separate the shirts from the socks so you don't waste time.
Yeah, you don't want to be searching through a pile of socks for a shirt.
Right. And this filtering, it's simple, but it can make brute force surprisingly effective.
Okay, but how do we implement that filtering? We don't want to go through our whole dictionary every time.
You're right, that wouldn't be efficient.
So what do we do?
One way is to use a hash map.
Okay, a hash map. How does that help us?
Imagine creating buckets for each word length. So all the 3-letter words go in one bucket, 4-letter words in another, and so on.
I'm with you.
The hash map then connects the length to the correct bucket.
So when I search for at,
Yeah.
I go to the 3-letter word bucket,
Exactly.
and then I can do my brute force comparisons there.
You got it. It's still brute force, but in a smaller, more targeted space.
I like it. Brute force, but with a little finesse.
Exactly.
And this approach, it's competitive, you said.
Especially for data sets that aren't massive. Yeah.
Okay, cool. So we've explored 2 main strategies here,
Mm-hmm.
using a try,
Yeah.
with or without memorization,
Right.
and then optimizing brute force with this length-based filtering.
It seems like each approach has its strengths and weaknesses.
Yeah, for sure.
There's no one-size-fits-all solution here.
So how do we choose? What's the best way to decide which approach is right for a given situation?
That's a great question, and it's something we're going to delve into in much more detail.
Okay, perfect. So I'm definitely curious to hear more about that.
Yeah, let's break down those trade-offs and figure out the best tool for the job.
Sounds good to me.
All right, let's dive in. It really comes down to understanding those trade-offs. Let's start with the try. It's really good at those prefix-based searches.
Okay.
Like think about autocomplete. As you type, the try can really quickly narrow down the possibilities because it's already organized by those shared prefixes.
So if I'm building autocomplete,
Yeah,
try seems like the way to go.
it's a strong contender, for sure.
But what about those searches that are heavy on the wildcards?
Mm-hmm. That's where it gets a bit more complicated.
Okay.
Remember all that branching out we talked about?
Yeah, the choose your own adventure for words.
Exactly. If you've got a ton of wildcards in your search, you might end up exploring a lot of paths that don't actually lead anywhere.
So it's like too many options, too many dead ends.
Yeah, you could say that.
And that's where memoization comes in.
Exactly. If you're doing the same searches over and over again, memoization can really save you some time.
Right, because it remembers the answers.
Exactly.
Yeah.
It's like having a cheat sheet for your word searches.
But that cheat sheet, it takes up space, right?
That's the trade-off. Memory usage.
So try plus memoization.
Mm-hmm.
It's a speed boost, but it costs you some memory.
Precisely. You're kind of investing some memory up front to get those faster search times later on.
Makes sense. Okay, so what about our optimized brute force then?
Ah, yes, the underdog.
When does that one make the most sense?
Optimized brute force really shines when you've got a moderately sized dictionary
Okay.
and you're looking for a solution that's, relatively simple.
Right.
That length-based filtering, it can really cut down the number of comparisons you need to make.
It's like knowing which shelf to look on in the library.
Yeah, exactly. You don't have to search the whole building.
So it's efficient in its own way.
It can be surprisingly efficient, especially if you're not working with a massive data set.
And I imagine it's probably easier to understand and implement than a try.
Oh, absolutely. If you're looking for something straightforward, optimized brute force can be a good choice.
So it's really all about picking the right tool for the job.
Exactly. You've got to consider the problem, the size of your data, and what kind of performance you need.
Right, so there's no one best solution.
Not really, no. It depends.
Okay. And we've got these three approaches, but I imagine there are even more out there.
Oh, absolutely. The world of algorithms is vast.
So if someone wanted to go even deeper with this, what else could they explore?
Well, there are things like suffix trees, for example.
Suffix trees, okay.
Those are designed for multi-pattern string matching.
So even more complex scenarios.
Yeah, and there's the Autocomplete algorithm.
Wow. I'm going to have to look that one up.
It's pretty cool. It's all about finding multiple keywords in a text.
Sounds like a whole other deep dive right there.
Maybe someday.
Okay, so we've covered a lot of ground here.
We have, yeah.
Brute force,
Yeah.
tries,
Memoization.
length-based filtering.
Even some more advanced algorithms.
This has been a really fascinating deep dive.
I agree. Wildcard searches, they're trickier than they seem at first glance.
Yeah, for sure. But hopefully our listeners are feeling inspired to tackle this challenge themselves now.
I hope so. And maybe even come up with their own creative solutions.
Exactly. And if you want to dig into the actual code for all this, we've got you covered on AI.Code.Cast.
We've got detailed explanations, code examples, even some visualizations.
So be sure to check that out.
Absolutely. And until next time, happy coding.
So we've got these three approaches, each with its pros and cons. How do we know which one to pick? When does a try win out?
Well, like we said, tries are amazing for those prefix searches.
Right, like autocomplete, that makes sense.
Exactly. When you're typing, the try can quickly narrow down the possibilities because it's organized by those shared prefixes.
Yeah, but what about those wildcard-heavy searches? Does the try still hold up?
It can struggle a bit there. Remember, every time we hit a wildcard, we have to explore every branch.
Right, like choosing your own adventure, but with way more possibilities.
Yeah, exactly. And that can get computationally expensive, especially with lots of wildcards.
So tons of wildcards, maybe not the best for a try.
Right. That's where memoization can help, though, if you're doing a lot of the same searches repeatedly.
Right, because it remembers the answers from before.
Exactly. It's like having a cheat sheet for all those tricky searches. But that cheat sheet does take up space, of course.
Yeah, the memory trade-off.
Yep. You're trading some memory for speed.
Okay, so try with memorization is good when you need things to be fast and you've got the memory to spare. But what about our optimized brute force? When does that shine?
Optimized brute force is great when you have a data set that's not super massive, something manageable, and you want something that's easier to wrap your head around.
Right, it's more straightforward.
Yeah, exactly. And that length filtering, it's simple but surprisingly effective.
It's like knowing exactly where to look in the library instead of wandering around aimlessly.
Exactly. And the beauty of it is its simplicity. If you need something that's easy to understand and implement, optimized brute force can be a great option.
So it really comes down to understanding the problem, how big your data is, and what kind of performance you need.
Absolutely. There's no one perfect solution. It all depends.
That's a good point. And, we've focused on these three approaches, but there are even more out there for the really curious folks.
Oh, yeah, absolutely. There's a whole world of algorithms for string searching and pattern matching, like suffix trees, for example.
Suffix trees, okay.
Yeah, they're specifically designed for those more complex scenarios where you're searching for multiple patterns. And then there's the Autocomplete algorithm.
I'll have to look that one up.
It's pretty neat. It lets you find multiple keywords within a text very efficiently.
Sounds like a deep dive for another day.
Well, I think we've covered a lot of ground here.
We have. Wildcard searches, they're sneakier than they look.
Yeah, more to them than meets the eye. But hopefully our listeners are feeling a bit more equipped to handle them now.
I hope so. And maybe even come up with some clever solutions of their own.
Exactly. And of course, if you want to go even deeper, we've got you covered over at AI.Code.Cast.
Yep, we've got detailed explanations, code examples, visualizations, all that good stuff. So be sure to check it out. Thanks for joining us on this deep dive into wildcard searches, and until next time, happy coding.